Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the scatter graphs practice questions. If you need any extra help on scatter graphs, if you go to corbettmaths.com/contents and scroll down to video numbers 165 to 168. Alternatively, you could scan this QR code and that'll bring you to the videos directly. But in this video, we're going to focus on the video solutions to scatter graphs, so let's get started. So question number one. Question number one says 8 students had a music test. The table shows information about how many hours of lessons they had and the number of mistakes they made in the test. So for instance, this student had 8 hours of lessons and made 8 mistakes. This person had 2 hours of lessons and made 12 mistakes, and so on. And part A says show this information on the scatter graph below. So let's do that. So the first person had 8 lessons and made 8 mistakes. So let's go down. We want to do 8 lessons and 8 mistakes. So we go up to here, put a point there, a little cross there. Next, the next person had 2 lessons and made 12 mistakes. So 2 hours of lessons and made 12 mistakes. So they would be up there. The next person had 5 hours of lessons and made 7 mistakes. So 5 hours of lessons and made 7 mistakes. So that's going to be there in between 6 and 8, so 7. So 5 hours and 7 mistakes. Next person had 3 hours of lessons and made 9 mistakes. So 3 hours of lessons, so that would be here, and going up to 9 mistakes would be there. The next person had 10 hours of lessons and made 2 mistakes. So 10 hours of lessons and made 2 mistakes there. The next person had 7 hours of lessons and made 6 mistakes. So 7 hours of lessons and made 6 mistakes. So go from 7 up to 6 there, like so. And then the next person had 11 hours of lessons and only made 1 mistake. So 11 hours of lessons and made 1 mistake would be there. And finally, the last person had 6 hours of lessons and made 5 mistakes. So we go to our scatter graph, we go across the 6 hours and go up to 5 mistakes, and that would be there. So we've plotted our points, and let's just check 1, 2, 3, 4, 5, 6, 7, 8. Fantastic. Okay, and the next part says a student is awarded a prize if they made less than 3 mistakes. So in other words, if they made 2 mistakes, 1 mistake, or no mistakes, they're awarded a prize. If they made 3 or more mistakes, they didn't get awarded a prize. And the question says how many students are awarded a prize. So one way we could do is look at our table and see how many students made less than 3 mistakes. So no, 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 no. They made less than 3 mistakes, so they'll be awarded a prize. No, yes, and no. So 2 students are awarded a prize. Alternatively, we could look at our scatter graph, and if they made less than 3 mistakes, they're awarded a prize. So if we go to 3 mistakes, which is here, and we go across and draw a line, anyone below that line will be awarded a prize. So that means that this person and this person are awarded a prize. So how many people are awarded a prize, or how many students are awarded a prize? The answer is 2. Okay, and part C says complete the sentence below. Generally, the more hours of lessons, the something mistakes are made. So let's have a look at our scatter graph. The more lessons that they had, the less mistakes that they made. As you can see, the graph is going down this way, so it means as they have more hours of lessons, they make less mistakes. And actually you can see that from the table. The people who had more hours of lessons made less mistakes. So for instance, this person had 11 hours, only made 1 mistake. This person had 10 hours, only made 2, and so on. But looking at our scatter graph, we can see that more clearly, that as they have more lessons, they made less mistakes. So the more hours of lessons a student has, the less mistakes are made, or the fewer mistakes are made. And that's it. Okay, let's have a look at our next question. Question number 2. So question number 2 says the value of cars in a used garage are recorded below. So we've got the scatter graph, and we've got the values of the cars. So this car, for instance, is £9,000 value. This car down here has got a value of £1,000, and so on. And we've got the age of the car, because obviously it's a used car garage, so they've got a certain age. So here's a 5-year-old car that has a value of £5,000, and so on. And then if we have a look at it, it says another car arrives at the garage. The car is 4 years old and has a value of £5,000. Show this information on the scatter graph. So the car is 4 years old, so let's go across to 4, and it is worth £5,000. So if we go up to 5,000, that would be here. So let's put a little cross there for it. Okay, so that's part A done. Part B says describe the correlation between the value of the car and the age of the car. So remember our correlation, because this is going downwards, like so, that's a negative correlation. It means that as one value increases, the other one goes down. So for instance, as the age increases, so as the age is increasing, the value is going down. So that's a negative correlation. So that's a negative correlation. If the points were going up this way, it'll be a positive correlation. And if they're just scattered around in a random manner, that's no correlation. So the question says describe the correlation between the value of the car and the age of the car. It's a negative correlation, negative. as the age goes up, the value goes down. Okay, let's have a look at our next part. The next part says the next car that arrives is 6 years old. Estimate the value of the car. So what we're going to do is we're going to go up to our scatter graph and we want to estimate the value of a 6-year-old car. Now we're not just going to go up and pick a random number there. What we're going to do is we're going to use a line of best fit. Now at GCSE level, we're just going to do the best we can. As you study statistics further on, you'll find out there's a way to do it. But at GCSE level, we're just going to get a ruler and pencil and you're going to draw a line of best fit so that it looks like it goes through the points so that you've got roughly the same number on both sides, and that's the line of best fit that I've drawn. Now, obviously, you may have drawn a line of best fit that's slightly different, and that will affect your answers whenever you're doing these questions. So whenever you're doing an exam question, you'll find that there's a sort of a range that you're allowed to be in between, because they understand that the lines of best fit aren't all going to be the same. So that's the line of best fit that I've drawn, and we want to estimate the cost or the value of a 6-year-old car. So what we're going to do is we're going to get a ruler and pencil, and we're going to go to 6 years old, and we're going to get a ruler and pencil and go up to that line of best fit, so like so. And I draw that on the page just so I show the examiner what I'm doing, and I go across, and that brings me to here. So that's the value of the 6-year-old car. Now let's look at our scale and work out how much or what value that car would have. So to get from 0 to 1,000, to go from £0 to £1,000, we're going up in 200s. 200, 400, 600, 800, 1,000. So here's 3,000, 3,200, 3,400, 3,600. So based on my line of best fit, the value of a 6-year-old car would be 3,600. Now it's possible that if you've done this set of questions at home and you've drawn your line of best fit, you may have had a slightly different line of best fit and your value may be slightly different. But as long as you've drawn a good line of best fit that goes through as many points or as close to the points as possible, and that you've drawn up and across and you've done that properly and you've read off the right number, you'll get the mark. Okay, so that is £3,600. And that's it. Okay, let's have a look at our next question, question number 3. So question number 3 says the table shows the time spent revising and the test scores of 10 students. So here we've got 10 students, 1, 2, 3, 4, 5, 6, 7 that are in red, and then we've got 3 that are in green, 8, 9, 10. And it says the first 7 points have been plotted. So the first 7 points have been plotted on this scatter diagram. And we've got 1, 2, 3 left. And part A says complete the scatter diagram. So we need to plot these points. So this person spent 7 hours revising and got 70%. So let's go to 7 hours. So 7 hours and up to 70%. So that would be there. Next, the next person spent 5 hours revising and got 60%. So let's go to 5 hours and up to 60%. So that's there. And the last person spent 8 hours revising and got 86%. So they revised for a bit longer and got a higher score. So there's 80. Now we're going up in twos here. So 82, 84, 86. So that's there. So 8 hours and 86%. And so we've plotted those points. That's part A done. Part B says describe the relationship shown in the scatter diagram. So we've got these two lines. So we're not just looking for the correlation. So that would be a positive correlation as the hours spent revising goes up. So as the hours spent revising or the time spent revising goes up, the test score goes up. But we've been asked to describe it. So I'm just going to describe that in words. So I'm going to say as the time spent revising goes up, the test score goes up. So let's do that. And that's it. So I've just written, as the time spent revising increases, the test score increases. So that's describing the relationship. Okay, and then part C. Part C says draw a line of best fit. So we need to draw a line of best fit on this diagram. And remember, we just want to draw us the best that we can, and they may vary slightly. So let's do that. So that's my line of best fit. And then part D says, another student has spent 4.5 hours revising. Use your line of best fit to estimate their test score. So let's go up. So they've spent 4.5 hours revising. So get a ruler and pencil and go up to our line of best fit. So let's go to 4.5. So 4.5 would be here in the middle of 4 and 5. And we're going to go up to the line of best fit, which would be there, and then across. So across from the line of best fit to our vertical axis. And let's read off and see what test score that would be. Now remember, we're going up in twos, 2, 4, 6, 8, 10. So it's 50, 52, 54, 56. So I've got that's equal to 56%. Now, if your line of best fit is slightly different, so you may have got 55 or 57% or something like that. But as long as you've used your line of best fit properly and gone from 4.5 up and then across and done that without going sort of up or down or whatever, then you should get the mark. So that's it. So 56%. Okay, let's have a look at our next question. So our next question is question number 4. And question number 4 says the scatter graph shows information about the heights and arm spans of 10 students in school. So we've got their arm span gone up vertically and we've got their height going across horizontally. So we've got their height this way and our arm span this way. And then the question says what type of correlation does the scatter graph show? So as you can see, as the height increases, as the height's increasing, so as the height's increasing, the arm span's increasing. So the graph is going up this way, the points are going up this way. way. So it's got a positive correlation. So the question says what type of correlation is shown? Positive. Okay, then we're told another student has a height of 150 centimeters. Estimate the arm span of this student. So let's go up and draw a line of best fit, and then we can estimate the height of that student. So I've drawn my line of best fit. Now remember, your line of best fit may be slightly different, but that's my line of best fit. And the question said that the student has got a height of 150 centimeters. So the height of 150 centimeters, so we're going to go up and across, and then read off what arm span they might have, and that's our estimate. So let's go from 50 centimeters up to the line of best fit, and then across. So I've got us just below 150. And then if we have a look at our scale, so that's 100 and that's 110. So 102, 104, 106, 108, 110. So we're going up in twos. So here we've got 140, 142, 144, 146, 148. So that would be 149. So the arm span of this student would be 149. That's our estimate. So let's do that. So let's write that down. 149 centimeters. And that's it. Okay, let's have a look at our next question, question number 5. So question number 5, we've got here the charge by plumbers for some jobs of different durations. So we've got the duration, 1 hour, and that costs £60. 2 hours, that's £80. 3 hours, that's 104. Another job which lasts 3 hours, that's 116, and so on. And part A says plot the data, or the data, on the scatter graph below. So let's plot the data, or the data, on the scatter graph below. So 1 hour is £60. So let's go to 1 hour, and then up to £60. So that's our first point there. Our next point is 2 hours, £80. So 2 hours and then up to £80, like so. Next, we've got 3 hours and £104. So let's go for 3 hours and up to 104. So we've got 100. Now let's check where we're going up in here. We're going from 100 to 120. So we're not going up in twos because that'll be 102, 4, 6, 8, 110. So let's check if we're going up in fours. 104, 108, 112, 116 and 120. So we're going up in fours. So we wanted 3 hours and £104. So that's just going to be one box above the 100 there. So it's going to be there 3 hours and then 104. Next was 3 hours and 116. So that's 3 hours and then that's 104. So 108, 12, 16. So it's just one box below the £120 there. Next, 5 hours and £128. So 5 hours and 128. So 5 hours, 120. Now we're going up in fours. 124, 128 will be there. Next, we've then got 6 hours and £140 and 6 hours and £160. So let's plot those on the graph as well. So 6 hours and £140 would be there, and 6 hours and £160 would be there. So we've plotted 1, 2, 3, 4, 5, 6, 7 points, and let's just go up. We're told it's for 1, 2, 3, 4, 5, 6, 7 points. So that's it. So we've done part A. Part B. Part B says describe the correlation. So we've been asked to describe the correlation. So it's a positive correlation. And we can tell it's a positive correlation because as the duration is going up, the charge is going up. So we can write that down and then let's describe it as well. So it is a positive correlation because as the duration increases, so does the charge or the cost. And that's it. So the charge increases as the duration increases. So that's a positive correlation. Okay, next, if we turn over, we've then got part C. Part C says draw a line of best fit on the scatter graph. So let's go back. We want to draw a line of best fit on this scatter graph. And remember, ours may vary slightly. So let's get our ruler and pencil and draw a line of best fit. So that's the line of best fit that I've drawn. It looks something like that. And then we've done part C, we've drawn our line of best fit. And part D says use your line of best fit to estimate the charge for a 4-hour job. So we want to find the cost of a 4-hour job. So 4 hours is here. So we want to go up and across. So let's get our ruler and pencil and let's go from 4 hours up to here and across to there. And as you see, that's one box below 120. Now each box was worth 4. So one box below 120 would be 4 below 120, which is £116. So let's write that down, £116. Okay, and then part E. Part E says explain why it may not be appropriate to use your line of best fit to estimate the charge for a job lasting 12 hours. So if we have a look here at our graph that we've got points to go up to 6 hours. And then we don't have any more points. And 12 hours would be really far along. And in terms of a plumber doing a job, 12 hours is a very long time to be at a house. It may be that for a 12-hour job, they would do maybe so many hours on the first day, go back home, go back the next day, and then finish it off. And then they may need to charge the travel costs twice. So there may be reasons to why this line of best fit may not be accurate or reliable for a 12-hour job. And the main reason is that we've only got data for between 1 hour and 6 hours. So it's beyond the range of the data that we've been given. Our data only goes up to 6 hours, so it's unreliable. Once you go past that 6 hours, we don't know what's going to happen. He may start charging double time, triple time, extra time, bonus time. He might actually, because it's such a big job and maybe he made a mistake, it might be that it actually gives a discount or something, but that's probably unlikely. But it's beyond the range of the data, so let's explain that. It is beyond the range of the given data. And that's it. So I've just written down it is beyond the range of the given data. So it's extrapolation, so therefore it would be unreliable. And whenever you're doing extrapolation, which is going beyond what you've been given and you're sort of predicting what's going to happen, that can sometimes be unreliable. So and that's it. So it's beyond the range of the given data. Okay, let's have a look at our next question, question number 6. So question number 6, we've got a scatter graph shows the age and values of some cars. So we've got the age here going along horizontally. So we've got some cars ranging from 1-year-old up to 12-year-old. And we've got their values, so from £20,000 going down to around about £2,000. And the question says, use the scatter graph to estimate the value of an 8-year-old car. So we want to estimate the value of an 8-year-old car. So let's draw a line of best fit. So let's get our ruler and pencil and draw a line of best fit. So I've drawn a line of best fit and we want to estimate the cost or the value of an 8-year-old car. So let's get a ruler and pencil and go up to the line of best fit and across, and then that'll give us our estimate. So let's do that. So if we go to 8 years old and up to the line of best fit and across, and remember that our line of best fits may vary slightly, and I've got that, if I look at it, I can see that's the third box above 8,000. 1, 2, 3, it's the third box above 8,000. And let's work out what each little box is worth. So we've got 4,000 here, and there's 5, 10 boxes, so 4,000 divided by 10 would be 400. So we're going up in 400s. So that's 8,000, 8,400, 8,800, 9,200. So for me, the value that I've got for an 8-year-old car, our estimate would be 9,200. Now, if your line of best fit's slightly different than mine, then your estimate may be slightly different. And that's it. So 9,200. Okay, let's have a look at our next question. Okay, so let's have a look at question number 7. So question number 7 says, some rugby players take 2 tests, one measuring their speed and the other measuring strength. And each test is marked out of 200 and the scatter graph compares the results. So they're given 2 tests, they're given a score out of 200 for each of them, and the scatter graph shows their results. So we've got test 1 and test 2. Now we're not told which one's which. We've got the test 1s out of 200 and test 2s out of 200, and these are the points. And as you can see, it's a negative correlation because as the result in test 1 increases, the result in test 2 decreases. And perhaps that might make sense that, in terms of rugby, the really fast players might not be as strong as perhaps, a prop forward or one of the front row. Whereas the front row, like myself, we may be a bit stronger than some of the faster players. And part A says, what type of correlation does the scatter graph show? Well, as I've said, it's a negative correlation. As test 1 results increase, the test 2 results decrease. The points are going downwards like so. So that's a negative correlation. So let's write that down, negative. Okay, part B. Part B says, draw a line of best fit on the scatter graph. So let's draw a line of best fit. So that's the line of best fit that I've drawn. Remember, yours may be slightly different, but that's the one that I've drawn. And then we're told that Brian scores 40 in test 2, and we've been asked to estimate his score in test 1. So he scores 40 in test 2. Now test 2 is here, so we're going to go to 40 in test 2, which is there, and we're going to go across from 40 in test 2, across to the line of best fit and down, and that'll give us our estimate for his result in test 1. So let's see what he gets, or let's see our estimate. So let's get our ruler and pencil and go across from 40 to the line of best fit, and then down. And I've got that's 140. So he got 40 in test 2, and then we've gone across and down, and then our estimate for his result in test 1 would be 140. So let's write that down, 140. And 140 points in test 1, and that's it. Okay, let's look at our next question, question number 8. So question number 8 says, Samia records the ages and masses of 10 Jack Russell dogs. So there's 10 Jack Russell dogs, A, B, C, D, E, F, G, H, I, J. Let's just check this 10 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And we've got their ages and their mass. So we've got a 4-month-old dog, our Jack Russell, and it weighs 3.2 kilograms. We've got a 10-month-old dog, and it weighs 4.7 kilograms, and so on. And the points for the first 8 dogs have been plotted. So from A to H in blue blue here, they've all been plotted, but the last two, I and J, those 2 points, the one that is 6 months old and weighs 4.2 kilograms and the 8 months old and weighs 4.4 kilograms, they haven't been plotted, so let's plot them. Or I'm guessing that's what part A tells us to do. So part A says plot the 2 points for the remaining dogs. So 6 months old and 4.2. The 6 months old is here, and we're going to go up to 4. Now we want to go to 4.2. Let's see what each one of these little boxes are worth. So we've got 10 little boxes between 4 and 5, so that means each one must be 0.1. So we've got, if we go up to 6, so if we go to 6 again, we've got 4, then 4.1 and 4.2. So that would be there. The 6-month-old dog weighs 4.2 kilograms, and we've plotted that point. Next, there's an 8-month-old dog, and it weighs 4.4 kilograms. So let's go to 8 months and go to 4.4. So 4, 4.1, 4.2, 4.3, 4.4, and plot that point. So it's there. So we've plotted those 2 points, that's part A. And then if we turn over, and then we're told an owner claims his Jack Russell is 4 months old and weighs 6 kilograms. Does the scatter graph support his statement? Explain your answer. So let's go to the scatter graph. So he's saying his dog is 4 months old, so 4 months, and he's saying it's 6 kilos, 6 kilograms. So if we go to 4 months, so 4 months, which would be here, he's saying it's 6 kilograms, which is actually quite high up. I'm just actually going to plot it and see where it would be. So 4 months would be here, and if we go up to 6 kilograms, that's up there. That's actually heavier than all the dogs we've been told. If we actually have a look, none of the dogs, even the 12-month-old dog, doesn't have a mass of 6 kilograms. So unless this 4-month-old dog is really, really heavy, or maybe it's not a Jack Russell, or who knows, but it doesn't look like that point fits in with the rest of the data that we've been given. So I would say that's an outlier, and I would question the reliability of that. So let's get rid of that point. It shouldn't be there, maybe. Okay, so does the scatter graph support his statement? I'm going to say no. It would be an outlier. It would be an outlier. Okay, and then part C. Part C says explain why the scatter graph may not be used to estimate the mass of an 8-month-old poodle. Well, if we have a look, our scatter graph was for Jack Russell dogs, and poodles and Jack Russells are different breeds, so the masses of those dogs, poodles, might be completely different to the masses of Jack Russells. So this graph is useful for Jack Russell dogs, but I wouldn't say I would use it for poodles, so let's explain that. And that's it. So explain why the scatter graph should not be used to estimate the mass of an 8-month-old poodle. Well, I've said the scatter graph is for Jack Russells, not poodles, so it shouldn't be used. Okay, let's have a look at our next question, question number 9. So question number 9 says, class sits test 1 and test 2. So they sit test 1 and test 2, and Arthur plots the scatter graph and draws a line of best fit. So he plots the scatter graph, so he plots all the points, and then he draws that line of best fit. And then the question says, give a criticism of Arthur's line of best fit. Well, if I actually have a look at that line of best fit, I don't think it's as close to the points as it could be. I would have drawn a line of best fit that looked more like this. So I would have drawn a line of best fit that perhaps looked more like that, going through or going close to as many of the points as possible. I think Arthur's started his line of best fit at the origin. He thinks that perhaps it has to start at the point 0, 0 and goes up. And actually, sometimes whenever I'm marking students' work, I find that's the case. Sometimes I think that a positive correlation, the line of best fit has to go through that, but it doesn't. I would actually draw a line of best fit that looks something more like that because it's closer to the points. So let's explain that. So I've written down, it doesn't have to go through the point 0, 0. That's one criticism. It doesn't have to go through that point. And the other criticism, which I think is the one that I would probably opt for, is it could be a lot closer to the points. I think the line of best fit could be a lot closer to the points than the one that he's drawn. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 10. So question number 10 says, a shop sells umbrellas, and the scatter graph shows information about the number of umbrellas sold each week and the rainfall that week in millimetres. So we've got the amount of rainfall that week in millimetres and the number of umbrellas sold. So going across horizontally is the rainfall, and going up vertically is the number of umbrellas sold. And part A says, describe the relationship between the rainfall and the umbrellas sold. Well, as you can see, as the rainfall increases, the number of umbrellas sold increases as well. It's got a positive correlation. It's going upwards. So let's write that down. And that's it. So I've just written, as the rainfall increases, the number of umbrellas sold increases. And that describes the relationship. Okay, let's look at part B. Part B says, what is the most number of umbrellas sold in 1 week? So we're going to look for the week where the most number of umbrellas sold is. So if we have a look vertically, that's the number of umbrellas sold. Let's see what we're going up in. So going from 0 to 15, there's 5 little squares. So 15 divided by 5 is 3. So 3, 6, 9, 12, 15. Fantastic. So we're going up in 3s. The week where the most number of umbrellas sold is this week here. That's the week because it's the highest point. It's the one that goes up the highest. So that would be the greatest number of umbrellas sold. So let's go across and see how many umbrellas were sold that week. So if we go go across using our ruler and pencil, we get to here. Now remember, we're going up in 3, so that's 108, 111, 114. So the week where the most number of umbrellas sold, there was 114 umbrellas sold. So let's write that down. It says, what was the most number of umbrellas sold in 1 week? The answer is 114. Okay, let's look at our next page. Let's turn over. So part C says, what's the greatest amount of rainfall in 1 week? So let's go back to our scatter graph. So the greatest amount of rainfall. So the rainfall is going across horizontally. The greatest amount of rainfall will be in this week here. That week's got the greatest amount of rainfall because it's the furthest to the right. So let's go down and see how much rainfall was in that week. So if we go down, we get to here. And let's see what we're going up in. So from 5 to 6 is 1, 2, 3, 4, 5. So it's not 0.1s, it might be 0.2s. 5.2, 5.4, 5.6, 5.8, 6. Yeah. So we've got 12, 12.2, 12.4, 12.6, 12.8. So that means there's 12.8 millimeters of rain. So that's how much rainfall was in that week with the most amount of rain. So let's write that down. 12.8 millimeters. Okay, and part D says, how many weeks did the shop sell over 105 umbrellas? So let's go back to our scatter graph. We want to see how many weeks did they sell over 105 umbrellas. So if we go to here, 105, and we get a ruler and pencil and we go across, all the points that are below that sell less than 105 umbrellas, and all the points above them are weeks where more than 105 umbrellas are sold. And as you can see, there's 1, 2, 3 weeks where there's more than 105 umbrellas sold. This week it's less than 105, so there's 1, 2, 3 weeks, and that's it. So 3 weeks. Okay, then we're told in another week there's 6 millimeters of rain. Estimate the number of umbrellas sold. So we want to estimate the number of umbrellas sold, so we're going to want to draw a line of best fit. So we're going to get a ruler and pencil, and I'm just going to get rid of some of this working out that we've done previously. So let's draw our line of best fit. So I've drawn that line of best fit, and the question says, in another week there was 6 millimeters of rain. Estimate the number of umbrellas sold. So as we're told, there's 6 millimeters of rain. So let's get our ruler and pencil and go up from 6 millimeters. So if we go up to the line of best fit and across, that's going to be 1 box above the 45, and we're going up in 3, so it's going to be 48. So there's 48 umbrellas, or our estimate for the number of umbrellas sold that week would be 48. So let's write that down, 48, that's our estimate. Okay, and then the question says, explain why it may not be appropriate to use your line of best fit to estimate the number of umbrellas sold in a week with 25 millimeters of rain. So let's go to our scatter graph and let's see where 25 millimeters of rain would be. Now, actually, if we have a look at our rainfall, the least amount of rain in a week was 5 millimeters, and the most amount of rainfall, or the greatest amount of rainfall, as we've seen, is 12.8. So with 25 millimeters, well, that's really far along. It's way beyond all the data we've been given. So we don't actually know what might happen if there's 25 millimeters of rain. For all we know, the people in the shop may close the shop that week if there's too much rain. I don't know. But we don't have as much of an idea of what happens whenever there's beyond 12.8 millimeters of rain. It's extrapolation. So let's write that down. It's beyond the range of the given data. And that's it. So we've just written down it's beyond the range of the given data, and extrapolation is unreliable. So if we extrapolate, if we make those predictions, it's unreliable. Okay, let's have a look at our next question. So question number 11. Question number 11 says, Mr. Hamill is a plumber, and the scatter graph shows the cost and length of his last 10 jobs. So we've got the length in hours and the cost. And the question says to circle the outlier. So if we have a look at these points, they're all sort of in this group here going up diagonally. There's this positive correlation. As the length increases, the cost increases. But this point over here, it's actually got a really expensive cost for the amount of time. It took 1.5 hours, or an hour and a half, but it cost well over £200. So that's sort of actually more expensive than all the other jobs. Perhaps it was an expensive part, or perhaps he had to travel a long distance to get there. So the question says circle the outlier, so I'm going to circle that one. Okay, let's have a look at our next question, question number 12. Okay, let's have a look at our next question, question number 12. So question number 12 says, the table shows information about the monthly rent of an apartment and the distance of the apartment from the city centre in miles. So for instance, this apartment is 3.2 miles from the city centre, and the monthly rent is £340. And we've been asked to plot that information, that data, on the scatter graph below, and to clearly label your axes. So I'm going to do that now. Okay, so I've plotted the points on the scatter graph, and as you can see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're told to describe the relationship between the distance from the city centre and the monthly rent. So as the distance increases, the monthly rent decreases. So it's got a negative correlation. So let's explain that. And that's it. Okay, let's have a look at our next page. So we're then told an apartment is 2.2 miles from the city centre and to find an estimate for the monthly rent. So we want to estimate the rent for an apartment that is 2.2 miles away from the city centre. So let's draw a line of best fit. So our line of best fit would look something. Okay, so that's my line of best fit. Obviously yours may be slightly different. Now we want to estimate the rent for an apartment that is 2.2 miles away from the city centre. So let's get a ruler and pencil and go to 2.2. So we've got 2 and 3, so that's 2.2, 2.4, 2.6, 2.83. So we're going to cross some 0.2s. So that would be there, and across would be there. Now we're going up in 20s because it's 400, 420, 440, 460, 480, 500. So that would be £420. So let's write that down. £420 is our estimate. So let's write that down as our answer. So our answer would be £420. Now obviously yours may be slightly different depending on your line of best fit. Okay, let's have a look at question number 13. So question number 13, we've been asked to match each scatter graph to the best description of type and strength for the correlation. So here we've got some scatter graphs. We've got this one. Well, that's no correlation, so that's going to match up with that one. We've then got these two. This one's got a strong negative correlation and this one's got a weak positive correlation. So this one's strong negative because they're going down, so it's negative as one's increasing, the other one's decreasing, and they're quite closely packed together, so that's a strong negative correlation. This one, they are going up, so as one's increasing, the other one's increasing, but they're more spread out, so that's a weak positive correlation, and that's it. So the top one is no correlation, the middle one is weak positive correlation, and the bottom one is a strong negative correlation. Okay, let's have a look at our next question, question number 14. So question number 14 says 11 students sit exams in art, maths and biology, and the information about the results are shown in the scatter graphs below. So as you can see here, in terms of the art exam and the maths exam, we've got a negative correlation. As the art score increases, the maths score is decreasing. That's a negative correlation. In terms of the biology exam and the art exam, as the art scores are going up, the biology results are going down as well. So that's a negative correlation. So we've got a negative correlation and a negative correlation. And part A says, describe the relationship between the maths and the art scores. Well, that's a negative correlation, negative correlation. Part B says, describe the relationship or the correlation between the biology and the art exams. So the biology and the art, so biology and art is negative correlation as well. So that's a negative correlation. Okay, and then if we have a look at part C says, describe the correlation between the biology scores and the maths scores. Now if we go back up, we don't actually have a scatter graph with maths and biology. Now we could create one if we wanted to. We could create a scatter graph. So we could have biology that way and maths that way, or vice versa. And we could look at the scores of each student. So for instance, this student here, this student in art, they scored, now we're going up in 2, so that's 76%. So that means that in their maths, they scored, here's going down in 2, so that's 16%. So this student scored 16% in their maths. And then if we look at their biology, they scored again in art, they got 76%. So this is the same student here. And in biology, they scored 8%. So that's 8% in biology and 16% in maths. So that would be 8% in biology, 16% in maths would be down there somewhere. Whereas if we looked at this student over here, they scored 10% in their art and then they got 72% in biology. The same student in maths got, well, 10% in art. So it's the same student, this student is that student. They got 10% in their art, they got 80% in their maths. So they got 72% in biology and 80% in their maths, so they're up there somewhere. And we could do this for all of the points. And if we've done that for all of the points, you'll end up with a scatter graph that looks something like this, which has a positive correlation. So because the maths and the art has a negative correlation and the biology and art has a negative correlation, the maths and biology will have a positive correlation. In other words, the students that are doing badly in art are doing well in maths. The students that are doing badly in art are doing well in biology. So that means they're doing well in maths and well in biology. Whereas the students who are doing well in art and well in art here, they're both doing badly in maths and biology, so they're doing badly in both of them. So that would be a positive correlation. So that means that it would be a positive correlation. So let's write that down, positive. And that's it. Okay, let's have a look at our last question, question number 15. So question number 15 says, the scatter graph shows information about the temperature and the number of passengers on 12 train journeys between a city and a seaside town. So these 12 points represent train journeys. So we've got these 12 train journeys and we've got the temperature along the x-axis. So here, whenever the temperature is 2.5 degrees Celsius, there's 200 passengers on that train. Whenever the temperature is 25 degrees Celsius, there's 400 passengers on the train. And that makes sense because probably maybe more people want to go to the seaside whenever the temperature is 25 degrees Celsius than 2.5 degrees Celsius. Okay, and if we go down, Jessica was the driver on one of the 12 train journeys. So she's the driver on one of these 12 train journeys. We don't actually know which one yet. So Jessica is the driver of one of these 12 journeys. And then we're told the temperature was 21 degrees Celsius. So let's find her train. So we're looking for 21 degrees Celsius. Now let's make sure we know what we're going up in here. So what we're going to cross in. So we've got from 0 to 5, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares. So if we do 5 divided by 10, that's 0.5. So we're going up in halves. So let's just check. A half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. So each little square going across is 0.5. Now she was the train driver whenever the temperature was 21 degrees Celsius. So that's going to be 2 little squares after the 20. So if we go across here, it's 2 little squares across. So it's not that one. The temperature on that train journey was 20.5 degrees Celsius. This one up here, that train there has got a temperature of 21 degrees Celsius because it's 2 little squares across from 20. That means Jessica was the driver of that train. And then we're told on that journey, the ratio of adult passengers to child passengers was 13 to 7. And then we're asked to work out how many passengers on that journey were children. So let's work out how many passengers were on her train in total. So let's get our ruler and pencil. And we know she's the driver of this train. So let's go across and we get to here. And then let's see what we're going up in. So to go from 0 to 100, there's 10 little squares, and that's 100. 100 divided by 10 is 10. So we're going up in 10. So we've got 300. 310, 320, 330, 340, 350, 360, 370, 380. So on the train that Jessica was driving, there was 380 passengers. And then the question says the ratio of adults to children were 13 to 7. So if we divide that 380 passengers, there's 380 passengers on the train. If we divide that in the ratio of 13 to 7, if we set in the ratio of 13 to 7, that'll tell us how many children were passengers on that train. So let's add together the numbers in the ratio. So we've got 13 parts plus 7 parts. That's 20 parts in total. So that means there's 20 parts in total. Now we know that there's 380 passengers. So if we divide that by the total number of parts, 380 divided by 20, that'll tell us how many passengers are in one part. So 380 divided by 20 is equal to 19. So that means there's 19 in one part. So that means if we take 19, the number in one part, and multiply that by the children's part in the ratio, which is 7, we do 19 times 7, that'll tell us how many children were on that journey. So 19 multiplied by 7 is equal to 133. So how many passengers on that journey were children? The answer would be 133. So these have been the video solutions to the Scattergraphs practice questions. I hope you found this video useful. If you have found it useful, please like it and subscribe to the YouTube channel. If you need any extra help on Scattergraphs, you can go to Corbettmaths.com/contents and scroll down to video numbers 165 to 168. There's various videos there on Scattergraphs that might help you. But again, I hope you found this video useful. Thank you. Cheers. Bye.